Alright, it is a happy Friday whenever I'm making this video. I don't know if it will be in years to come when you watch this video, but in 2018 it is a happy Friday, and it is the third part of our Zeros of Polynomial Function lecture. Today we are not live, so we will not have to sit through a bunch of wrong answers given by one of my classes. But to start off today, we're going to be doing the fundamental theorem of algebra. And it says that if f of x is a polynomial of degree bigger than bigger than 0, then f of x has to have at least one complex 0. It's going to be a theme today, is we're going to get complex zeros. If you remember, complex numbers are numbers that fit into that form a plus bi, a real part, and an imaginary part. Okay, so a couple corollaries to this theorem that I really like. It says that if we have a polynomial of degree n greater than 0, so f we get a polynomial, let's just say a third degree polynomial, okay, so that would be a cubic function, then that means if I was to factor it out, I should have exactly 3 linear factors. Well, from what we've been doing, what does that mean for us? It means that we'll have n roots if we allow for multiplicities. So today, the number of zeros we have will match the degree of our function. In the last 2 days, I've had a lot of questions asking me, hey, I got just this one answer. How come I didn't get 3 like the degree says? Well, it's because they were complex roots. So today we're going to be looking at matching that exactly. Now I'm going to have some good guesses for you today, so you don't have to worry about that. Okay? Hopefully I'll make the video a little bit shorter. But these problems are going to start a lot like the ones did yesterday, where I'm going to start with my P over Q list. And I'm just going to start guessing right here. I've had some pretty good guesses today so far. I think my first class came in and they just, boom, whipped out the right one. My next one came in, it was a little bit rougher. I'm just going to go ahead and guess the correct one. Okay, if you want to pause the video and guess some and try to get it, that's fine. But I will tell you that the one rational zero that works in this is the number 2. Okay, so whenever I go through and plug this in, I get this. So sure enough, yes, 2 is a rational zero. Okay, I got 0 in my denominator. It's looking a lot like it did yesterday, I know. So my resulting equation is x squared plus 4. Let me pause for a little bit. X squared plus 4. It is not factorable. All right, so that means I'm going to have, normally when something's not factorable, that means I need to resort to the quadratic formula or maybe completing the square. But I'm going to save the quadratic formula and completing the square for whenever I have something in the form ax squared plus bx plus c, when I have an a, b, and c. If I'm missing one of those letters, a, b, or c, I don't have to do a quadratic formula or completing the square. There's an easier way to solve it. For in this case, I'm missing b. So if I just simply subtract 4 from both sides, I get x equals plus or minus 2i. Remember that square root of 4 is negative 1 times 4. So the square root of negative 1 is I, the square root of 4 is 2. And those are my last 2 zeros. I have these 2 zeros, and I have x equals 2. And so that matches what I should have got. So if I take my complex zeros and my rational zeros, add them up, it should equal my degree up here. I got one more. Numbers got a little bit crazier on this one. I'm going to pause the video and work it. And so I suggest you do the same thing so you can make sure you're following along. I will tell you, if you're going to pause the video and work it, a positive fraction and then a negative integer work. So after you make your P over Q list, try a positive fraction and a negative integer. Haven't quite finished the problem yet. If you did finish the problem, hold tight. I'm going to work the end of it so you can see it. A couple notes I wanted to make before we kept going on this was that whenever I got down to here, I got the -4 to work. That gave me 3x cubed minus 13x squared plus 43x minus 13. Make sure once you get down to here that you revise your P over Q list if you can knock some values off. That would be something that would definitely be beneficial in not guessing so much on this. So indeed 1/3 did work. And so I get down to here and I've reduced all these numbers. I see that 3 goes into all of them, so I reduced it down to divide by 3, so I'm dealing with smaller numbers. Now, a lot of my students today are doing quadratic formula on it, perfectly fine. However, whenever this middle number right here is an even, I just can't help but to complete the square on it. Okay, so I'll take half of 4, which is 2, and square it. That gives me a 4. And so my left side is a perfect square trinomial. And my right side reduces or combines terms to give me -9. I get 2 nice squares right here. The square root of a negative is an I. The square root of a 9 is plus or minus 3. Subtract 2 from both sides. And I do get the same thing I get if I use quadratic formula on it. -2 plus or minus 3i. Make sure you bring over your other answers. I want to be able to see all your answers in one place. Okay. 4 answers, degree 4 polynomial, so I am good. Now, if you've noticed that on both of my first 2 answers, I got 2i and I got -2i. On this answer, what I just erased down here, I got, oh man, what was it? Drawing a blank. It was 2 plus or minus 3i, 2, yeah, and then I had 2 plus 3i and then 2 minus 3i, I think it was. And so we have a complex conjugate theorem. It's kind of the duh theorem where we're at right now, where it just simply says that if a plus bi comes out to be a 0, it's going to have a buddy that comes along with it that is also a 0, a minus bi. I say, well, yeah, Mr. Lovely, that makes sense because I'm taking the square root of both sides. I got to have that plus or minus. Or I'm using quadratic formula. The quadratic formula has a plus or minus sign built into it. And you're right, it does. We will always get both of those answers. But this comes in handy if I was to ask you to work the problem in reverse. It wants me to work a 3rd degree polynomial, meaning that it has 3 answers to it. And I'm telling you that 2 of the answers are going to be 5 and -2i. Well, I need 3 answers. So if -2i has to be a 0, then its conjugate, x plus 2i, has to also be a 0. So what I want to do is I'm going to do, this is like my last step. They told me all the zeros right here. I want to find the polynomial functions I can start my P's and Q's from. So right before this, I'm going to go ahead and write this as linear factors. So I'm going to take x minus each one of these zeros. So x minus a -2i would be an x plus 2i, and then x minus 2i. Okay. And just imagine if each one of these was set to 0, I would get back right up here where I started. But I'm wanting to work it in reverse. So I'm wanting to get rid of parentheses because nothing I've worked last couple of days have had parentheses. And the best hint I can tell you on this is FOIL together the binomials that look the same. So for instance, these two right here, I'm going to FOIL these together and get x squared. The outside is minus 2ix. The inside is plus 2ix. And the last term is minus 4i squared. Got some cleaning up to do here. I've got the x squared here. Minus 2ix plus 2ix, those just cancel. And my students have been good about it today, telling me that this I squared right here is a -1. So I have -4 times -1. That will turn it back into a +4. Got just a little bit more foiling to do. So the x cubed minus 5x squared plus 4x minus 20. Okay. that function right there, it's in parentheses, that has all the zeros I mentioned. However, they put some extra stipulations on it. They said, hey, we want to make sure that your function goes through the x-axis at -5, has these imaginary zeros, and goes through the point 1, 10. Has a function value at 1 of 10. Right? Well, remember, this is my x and y right here. So I can plug this in for my x and y. Let's see, I need 1 cubed minus 5 times 1 squared plus 4 times 1 minus 20. And so combining all these first three terms cancel and just leave me the -20. Divide by -20. And sure enough, my a is -1/2. So my polynomial, in order to go through this point of 110, has been squished by a factor of 1/2 vertically, and has been reflected over the x-axis. That all comes out right there with that a. So if I plug this a back in right here and distribute through, I get my polynomial function of -1/2 x cubed plus 5/2 x squared minus 2x plus 10. This right here has the imaginary zeros that I need, and it has the function value at 1 of 10. One more problem, kind of combines some ideas right here. Wilmo. Wilmo is designing a rectangular swimming pool that is to be set into the ground. It's a little guy, isn't he? So let's draw that rectangular swimming pool. It's just going to be a rectangular prism. All right, and it looks like we're basing everything off of the depth. The width of the swimming pool is 5 feet more than the depth. So here's the depth of it. So if the width is 5 feet more than the depth, I'm just going to take the depth and add 5 to it. While the length is 35 feet more than the depth. The pool holds 2,000. That should not be square feet. I apologize. I still need to change that. Cubic feet of water. I'm wanting the dimensions of this. We're talking about cubic feet. We're talking about a length, width, and height of a swimming pool. Then we're talking about volume, which is length times width, and in this case, times the depth. So I plug in what I know. I know the volume's 2,000. I know the length of it. Oh, it's not L plus 35. Sorry about that. D plus 35. And I know the width of it is D plus 5. And then there's the depth. Again, I want to get this into a polynomial that I can solve. So that means I need to get rid of my parentheses. So 2,000. First, outside and inside, 35 plus 5 is 40. Plus, 35 times 5, that's 175. Distribute this D through, and I'm going to switch sides as well to get it into this standard form. D cubed plus 40 D squared plus 175D. Subtract 2,000 off the other side. Set that equal to 0. Looking for zeros of this, looking for solutions. What can I plug in for D in order for this to work? Got a lot of wrong guesses this morning. Now, first of all, we're talking about the depth of a swimming pool here. And unfortunately, my P over Q is 2,000. I am not listing out all the factors of 2,000, so sorry about that. And I will tell you, I just pulled this picture off, so the depth is not 12 feet either. I don't even know what that number is. Is that a 6 or an 8? I don't know what that is. But think about the swimming pools I've been in. All right, I've had people say, well, 10 foot. 10 foot would make sense. We tried 10. We did not get 0 in the remainder. And they said, well, what about 8 foot? We tried 8. 8 is a factor of 2,000, but it did not work. The one number that we got to work was 5. Okay. I'll just show you that it does work. 545, 545 is 225. Add 175 to it, that's 400. Oops, positive 2,000. Got two positives there, make it positive. So 5 does work. The depth is 5. Well, length has to be 35 more than the depth. So I add 35 to it, I get 40. The width is 5 feet more than the depth. That's it. So these, I guess each one of these is in feet. These dimensions will what Little Mo's swimming pool will